Bismillahirrahmanirrahim. Assalamualaikum. In the last class, we talked about the design in the construction phase, and today we will study about making the diagrams that we talked about in last lecture. That we create the sequence diagram, we create the collaboration diagram. So today we will study the sequence diagram and the basics of sequence diagram. So a sequence diagram models the interaction between objects in a single use case. So if we have a use case in which we have got different actions, so sequence diagram tells us how that activity of that particular use case diagram will be done. So it describes us the sequence. Similarly, in fact, these diagrams, the sequence diagram illustrate how the different parts of a system interact with each other to carry out a function and the order in which the interaction occurs when a particular use case is executed. So it will tell us about the different components, different objects that interact with each other. In simpler words, a sequence diagram shows different parts of a system work in a sequence to get something done. So it will give us that particular sequence in which different objects or different parts of the system interact with each other. Second, sequence diagrams are time focused and they show the order of the interaction visually by using the vertical axis of the diagram to represent time, what message are sent or when. So whenever a message is sent, it comes in terms of time before the other messages. So all the messages are in a sequence in which they were sent or received purpose. In fact, this sequence diagram is a high level interaction between active objects in a system. It shows that interaction that is at the higher level. The interaction between object instances within a collaboration that realizes a use case. So, in fact, this diagram tells us how a use case is implemented or implementable in terms of its functionality. Similarly, the interaction between the objects within a collaboration that realizes an operation. So, how an operation is performed, how some task is done. So, this diagram shows us. So, how we draw that? First of all, there is a lifeline. Here you can see that a sequence diagram is made up of several of these lifeline notations. Lifeline notations that should be arranged horizontally across the top of the diagram. So, in fact, these lines, vertical lines, these are known as the lifelines, are displayed horizontally. One will be here, another one will be here. We will see those in detail, but in fact, this is the notation, this is the symbol. So no two lifeline notation should overlap. So these never overlap. These are parallel. They represent the different objects or parts that interact with each other. Like this is the object. So this line is telling us that from here, this object will interact with some other object. So here we will have another object, right? So a lifeline represents an individual participant in the interaction. So this is an individual participant. So this can be user, this can be system, this can be interface. So this is in fact the object, but we are talking about these lines, right? So lifeline, actor, a lifeline notation with an actor element. Look, now here we have an actor, right? Normally nowadays we are using just a rectangle over here. We write down inside that rectangle, but in fact, this is the real notation to represent if the user is a person, right? So now here, a lifeline notation with an actor element symbol is used when the particular sequence diagram is owned by a use case. So in a use case, we have the actor. So we are using that use case to draw this sequence diagram. So we will show the actor as it is, right? So sometimes we represent the same actor for system, for other objects, but normally it must be for the user. And look, it represents roles played by human users, external hardware, or other subjects. But normally, I must not suggest here we make the box and in which we write down the hardware, the camera, or anything that we are using, right? And for the actor, we use this actor symbol. Entity element, right? A lifeline with an entity element represents system data. So normally this kind of image in fact shows an entity and it describes in fact about the data and it system data and it shows that we are getting the message or we are sending the message to the system data. For example, in a customer service application, the customer entity would manage all data related to a customer. So it is going to interact with the data, right? It can be the bank data, it can be some other customer data. So this is the diagram. Control element. And a lifeline with a control element indicates a controlling entity or manager. Sometimes there is a controlling entity that controls what has to be done, but how it will be done. So, in fact, this image is shown as the control. Again, I will repeat, nowadays we do not use these particular symbols for the sake of simplicity, and we draw here only rectangles, and inside the rectangle we write down the control, but it is better to use the real symbols, right? It organizes and schedules the interactions between the boundaries and entities and servers as the mediator between them, right? So in fact, this is the mediator. It gets some message, it sends the reply, or it forwarded the message. So sometimes we need this control in our sequence diagram. Activation bar, a thin rectangle on a lifeline. This was the lifeline, and this a thin rectangle represents the period during which an element is performing an operation. So its length describes for how much time it is sending or receiving the messages. The top and the bottom of the rectangle are aligned with the initiation. We initiate it over here, right? We initialize something and then the completion times respectively. So here when it will complete, it will be closed over here. So now just check activation bars. So now here we have this message, it activates. This is the object, this is second object. Here we can draw an actor, here we can draw a control, here we can draw some other symbol, some system, some hardware. But now I'm saying object one and object two. So this object has some lifeline, and here we have got this particular area that we know we will call the activation bar. So here it is the activation bar. That means this object is active and it has started something. Here we can see another activation bar. It is active and now maybe it will send some reply and it will go from right to left, right? So in this way they are interacting with each other, right? So from this object to this object and then some reply, then some another message, then some acknowledgement or something. So they are talking to each other. Now, message arrows. An arrow from the message caller to the message receiver specifies a message in a sequence diagram. So here we can see this particular area from where we are starting some message, we are sending some message. It is initiation, we initiated something, and then this is the other object, it received the message. Okay, right? A message can flow in any direction from left to right, right to left, or back to the message caller itself. So it can move like this, or it can be sent from this object to this one. So the direction can be according to the requirement. So while you can describe the message being sent from one object to the other on the arrow with different arrowheads, you can indicate the type of message being sent or received. So in fact, this arrowhead sometimes describes the type of messages that we are sending or receiving. So now we have two types of message arrows, synchronous and asynchronous. A synchronous message is used when the sender waits for the receiver to process the message and return before carrying on with another message. So that means if we find this type of error, that means this object will not be able to initiate any other message until this particular object sends a reply, it responses, it performs the task, then it can move, right? So this particular arrowhead describes. So how can we call this arrowhead? The arrowhead used to indicate this type of message is a solid one. So this is filled with the color. Solid arrowhead, in fact, is used for the synchronous message. Now, asynchronous message is what? A, an asynchronous message is used when the message caller does not wait for the receiver to process the message and return before sending other messages to other objects within the system. So that means if I have sent one message to a object A and it is asynchronous, then it does not require that I will wait for the reply. I can send another message to the other object of the same system. The arrowhead used to show this type of message is a line arrow or a simple arrowhead. Now I can show you over here in this example. Object 1 is sending synchronous message. That means it requires some answer. It requires some processing over here, right? And when it will be done, then it can send to some other, right? And normally it says that as this always needs an answer, so normally we do not draw this line. But I always appreciate if this line or this message from object 2 to 1 is is defined, is shown, it is always good. But the book says as these there, it is obvious that it will send the message, then it will send the other message. So there is no need of it, but I feel it must be there. And now here we have asynchronous message, right? And then another asynchronous message because we did not need to get the reply. Here it is obvious and book says, in fact, it sent the reply. And when it got the reply, it started with another one, then with another one. So this is another example. This is simple asynchronous message. This is synchronous message. This is a call message. A message defines a particular communication between lifelines of an interaction. So from this object to this object, to this line, from this line, we send a message, right? Call message is kind of a message that represents an invocation of operation of target lifeline. So it asks this object to perform something or it activates it. So these are the messages to interact with each other. Return message. A return message is used to indicate that message receiver is done processing the message and is returning control over to the message caller. So if I look at this, this is a simple call message, and from here it will send it back a return message with some option. For example, if this message says check the pin code, and it will say uh, valid or invalid, right? So it will send the return message. This is about the return message. Return message are optional notation piece for an activation bar that is triggered by a synchronous message always implies a return message. So that means for the synchronous we normally do not draw, but I'll again say we must draw the return message. So now here, this one is the message going from object 1 to 2, and it processed and done what was required by the message 1, and then it is updating to the object 1 again. Object 2 is sending the return message. So now if I look at the book example, there is the system provides the present day's races. It is showing the races, all the races that are going to held on that particular day. The gambler, this is the user, he selects a race, then the system sends the horses that are taking part in that race, and then the user selects the horse, enters the stakes, and then confirms the transaction. And maybe there must be another line, the return line. The system must tell the gambler that, okay, your job is done. So this is a simple example for the simple notations. Another simple diagram, a user of ATM enters the card, ATM asks for the PIN, user enters the PIN, then ATM sends it to the bank or to the server for the verification. If it is valid, then it starts processing. It gives the, if it is valid, it gives you the options. It asks for the money withdrawal, and machine or ATM gives it the required amount. It is a lengthy process. We will study it in detail in the next class. But these are the very basic sequence diagrams for the learning at this level. Again, here is another option, that is operator panel. From it is an object, it is an interface, and from this panel we want to turn on the ATM machine. So we switch on message goes to the ATM. ATM performs a self test, right? This is with itself, and that it tells, okay, I'm on. It asks for the initial cache. Operate operator From operator panel we send the initial cache. Then it is set into the cashier dispenser. It is also sent a message to the network of the bank to get connected. So this is a sequence diagram in which we turn on or we start up an ATM machine, right? Here is another ATM example, and it is not the ATM example, McDonald's example. Customer places an order, customer pays money, then cash counter gives it the order confirmation, and cash counter sends the order preparation request to the food counter. And then food counter provides the food to the customer. This is another example. So this is another reading assignment. You will have to study the advantages and limitations of or disadvantages of that particular sequence diagram. And you will have also to study from the different websites and try to create a sequence diagram for your class project and submit it in the next class. Thank you very much. Assalamu alaikum.